This is question number 5 on the Fundamental Theorem of Calculus worksheet. It reads, evaluate the integral from 0 to 3 of the function x to the third. So the first thing that you want to do is find the antiderivative of the function x to the third, which we know is 1/4 x to the fourth. And we know this because you use the reverse power rule, which is 1 over n plus 1 times x to the n plus 1. So next you want to plug in values a and b, which is, this is a, and this is b. So you want to plug in these values starting with b, because you're going to use f of b minus f of a. So you're just going to take the antiderivative that you already found and first plug in b. So 1/4, 3 to the fourth. This is your first function. Minus 1/4, 0 to the fourth. I'm just plugging in a, which is down here. And when you do this out, for right here, you get 1/4 times 81 minus, and this just ends up being 0. So then for a final answer, once you combine these, you just get 81 over 4. And that's your final answer. You don't need a plus c because it's a definite integral. And number 6 on this worksheet is find the integral from 1 to 2 of the function x to the fifth. So the antiderivative of x to the fifth is, using the reverse power rule, is 1/6 x to the sixth. So now we have our antiderivative. We're going to again plug in the values a and b and subtract them using the fundamental theorem of calculus equation. So this is going to be 1/6 2 to the sixth minus 1/6 1 to the sixth. So now that we have this, we're just going to simplify it. This will turn into 1/6 times 64, because 2 to the 6th is 64. And this will just turn into 1/6, because 1 to the 6th power just equals 1. So now we have 64 over 6 minus 1/6, and when you do that out, you just get 63 over 6. And you just want to simplify this so you get a final answer of 21 over 2. These next two problems are going to be coming from this integration practice worksheet, because these ones can get a little bit more complicated as opposed to the one posted online. So a good one to start with looking at is number 18, because it's just an easy way to start to get the hang of using the reverse power rule. So the question for number 18 is just pi x, the integral of pi x. So a good way to look at this is just writing it as it's the same exact thing as pi x to the first, and seeing this is just an easy way to kind of know, okay, so when I do the exponent plus 1, it's going to equal 2. So just using this rule, it's just going to end up being pi over 2 x squared plus c. And you include the plus c in this as opposed to the last problem, because this is not a definite integral. There's not a defined a and b value, so that's why you need the plus c right here. So another number on this worksheet is number 13, and you should identify right away that you need to be using u substitution, because you can see in here this is the 7x plus 5 is the inside. So you should write it just to set everything straight. So the u equals 7x plus 5, and du over dx is 7, because the derivative of 7x plus 5 is 7, and that means that dx equals du over 7. So first, it's just the square root of u, because this whole inside we've already established is u. 1/7 du equals 1/7 times 2/3, and you're taking the antiderivative right here using the reverse power rule, times 3 over u squared. And we're not doing anything different, we're just using that same rule, plus c. And then if you simplify this, it's going to equal 2 over 21, and then plug back in your u, which is 7x plus 5, to the 3/2 plus c.